Here we will show how Apstra Cloud Services provides end-to-end assurance for business-critical applications. We will explore how infrastructure events in the compute layer, such as vMotions or backup file transfers, can increase the load on the fabric and trigger anomalies, like interface flaps, that impact the application performance. These kinds of anomalies can affect our other workloads running on the same infrastructure as well. In our scenario, the enterprise IT team reports that users are experiencing intermittent access issues with the CRM application. These problems have been occurring in the evening hours between 4 p.m. and 5 p.m. Wi-Fi and access point connectivity have been checked and ruled out, so the issue is escalated to the network admin for investigation on the data center side. During the day, the CRM application performs normally. Pages load quickly and users can easily navigate the interface. But in the evening, the application becomes unresponsive at times. Users are unable to load the home page or navigate through features, which disrupts their ability to work. Sometimes the pages eventually load after a delay, but the issue persists intermittently. When the problem is occurring, pages are slow or even completely stop loading at all. Fortunately, we have tools that allow us to look deeply at the network to determine the source of the problems quickly. The network admin begins by logging into Apstra Cloud Services and navigates to the impact analysis screen. They select the time window reported by IT, 4 p.m. to 5 p.m. Specifying the date and time allows us access to the historical data. Sliding through the 15-minute intervals within the time range, the admin observes anomalies between 4 and 4:30 p.m., specifically on the leaf switch. Several services are impacted by these anomalies, including the CRM application, which runs on port 8069. Expanding the anomaly view confirms that the CRM service hosted on hypervisor ESX01 is affected by the issue in the fabric layer. To investigate further, the admin moves to the Service Awareness page, which provides a comparison view for analyzing service topologies across the different time periods. The admin selects the same time window from the IT report for comparison. Here we're setting a date and time range so we can search through the historical data to find where the problems actually occurred. The comparison screen allows the admin to view changes in the 15-minute windows, side by side. Using sliders, they explore variations in service topologies before and after the anomaly occurred. The change panel highlights key differences between the two snapshots. A DNS VM that was initially connected to ESX01 is now in a disconnected state. A new DNS VM appears on ESX04. ESX04 itself, which wasn't in the previous topology, is now active. All of these changes are listed in the change panel with the option to drill into host-level details. With this information in hand, the network admin contacts the virtual infrastructure admin. The VI admin begins investigating ESX01, confirms that during the reported time period, a vMotion event was triggered and completed at 4:36 p.m. They also confirm that this is a scheduled vMotion performed daily during evening hours to consolidate VMs and shut down unused infrastructure to save power. Once the vMotion was completed, the anomalies in the fabric self-resolved. Since this was a scheduled vMotion, and it occurs regularly in the evening, the intermittent slowness experienced by users is an expected side effect of the compute load shifting across the fabric. By using end-to-end assurance with Apstra Cloud Services, the network admin was able to correlate compute events with fabric anomalies and trace their impact on application performance and pinpoint the root cause quickly and efficiently.